Example 1. A survey of 15 large U.S. cities find that the average commute time one way is 25.4 minutes. A Chamber of Commerce executive feels that the commute in his city is less and wants to publicize this. He randomly selects 25 commuters and finds the average is 22.1 minutes with standard deviation of 5.3 minute. At 10% significance level, is he correct? Assume that the population distribution of commute time is normally distributed.
On OPENSTAT, choose analysis, choose comparison, choose single sample test, choose this form, choose sample mean, go to sample statistics, which is 22.1, sample size is 25, sample standard deviation, which is 5.3, populations parameter 25.4. That will be the null hypothesis. Click on continue. That will be the result. In using the result, the null hypothesis is mu is equal to 25.4. The alternative can be taken as mu is less than 25.4, and here look for t-test statistics, which is minus 3.113 with a p-value of 0.005. Now the p-value is a two-sided type of p-value. Since the total area is 0.005, so the p-value we are looking at is on the left side, which is half of 0.005, which gives you 0.0025. So here you can reject H naught, since the p-value is smaller than alpha, which is 0.1.
Example 2. A real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the values of homes. A random sample of the two groups appraised 10 homes. The data are shown here. Is there a significant difference in the values of the homes for each group? Test at 5% significance level. Assume that both of the populations are normally distributed.
Go to analysis, choose comparison, go to test of two means, choose values entered on this form, and assume independent scores. Per sample 83256, standard deviation 3256, sample size is 10. Second sample 88,354, standard deviation 2341, sample size is 10. Click on continue, you'll get the result. To use the result, first of all, you need to test for the population's variance. In order to test this hypothesis, you will have to use the F-test. This is a test statistics. This is the p-value. So based on the p-value, you will fail to reject H0, since the p-value is always greater than alpha. Let's say alpha is 0.1. So you fail to reject the null hypothesis. continue. Therefore, we will be using assuming equal variances. And for that, the hypothesis will be as follows, which is mu1 is equal to mu2 against the alternative mu1 is not equal to mu2, and based on the p-value, this will be the test statistics, this will be the p-value. So based on the p-value, we can reject null hypothesis at alpha is equal to 0.05 since the p-value is smaller than the significance level.
Example 3. Each year, the state of Kentucky invites bids from dairies to supply half-pint containers of fluid milk products for its school districts. Data on all bids received from the dairies competing for the milk contracts during a period of time produces the results in the table below. Is there enough evidence to support that the mean bid prices in the Tri-County market is higher than the mean bid prices in the surrounding market? Test at 1% significance level.
Go to analysis, choose comparison, choose test of two means, choose values entered on this form, and also assume independent scores. For the first sample, the value is 0.1431 with a standard deviations of 0.0133. Sample size is 100. The second sample, the mean is 0.1331. Sample standard deviation is 0.0158. Sample size is 254. Press it continue. That is the result that you will get. And how to use the result? Test for equal variances. We use the F-test and we'll find that at alpha 0.05 we will reject the null hypothesis since the p-value is smaller than the significance level. Hence, we'll be using the unequal variance t statistics, which is 6.028 with a p-value of 0.000, which means very small. Again, what we want is to test whether the mean is equal against the alternative. One of the mean is greater than the other mean value. So here we can reject H0 since the p-value is smaller than alpha, which is 1% or 0.01.
Example 4. A consumer agency wanted to find out if the mean time it takes for each of 3 brands of medicines to provide relief from a headache is the same. 6 randomly selected patients were administered to each drug. The following table gives the time, in minutes, taken by each patient to get relief from a headache after taking the medicine. At the 5% significance level, will you conclude that the mean time taken to provide relief from a headache is the same for each of the 3 drugs?
In this example, you have to key in the values into OPENSTAT this way. One of the variable will be the drug, and the other variable is the time. Go to our analysis, choose ANOVA or analysis of variance, then click in the dependent variable and the factor variable, click in continue. This is the result that you will get. Here the p-value is smaller than the significance level, so you can reject the null hypothesis.